Okay, so in this section we're going to be talking about bond energies and what they are. So I'm going to pull up a table here, and this table lists all the average bond energies that you're going to be able to find and need to use in doing specific calculations. Now, when we talk about the enthalpy reaction, this is back in your thermochemistry chapter where you discussed how you calculate the enthalpy reaction, and where we looked up the enthalpies of formation. Now, the enthalpies of formation were based around the bond energies that are present in each of the molecules. So this table lists the bond energies, and these all are pertaining to the Lewis structures that you might draw. So a good example would be, let's say we have CH4. So if we wanted to figure out how much energy this molecule possessed, first thing we would do is we'd draw the Lewis structure. And the Lewis structure is very simple. It would just be a carbon with 4 hydrogens drawn around it. Now, if you look at this structure, you have a carbon-hydrogen bond, and that is the only type of bond that you have present. Now, looking at the table here, we need to find the carbon and hydrogen, and we see that in the top left in the second row. The carbon-hydrogen bond is 414 kilojoules per mole. Now, if we are to look at this molecule of CH4, there are 4 bonds. So what we would have to do to figure out the total energy of this specific bond in this molecule, we would have to take the 4 and we would multiply it by 414. And so for this specific molecule, we would have an energy of 1656 kilojoules. And so that's how much energy it would take to make that specific molecule of CH4. Now, what we're going to do with that is we're going to use that in a balanced equation, and we're going to work on solving for the enthalpy of reaction. So we're going to look at an example where we have hydrogen gas reacting with chlorine gas, and that's going to yield 2HCl. So the molecules are, the equation is balanced, so now we need to draw the Lewis structure for these molecules. So hydrogen gas is HH, chlorine gas is Cl, with the necessary dots around it, but those dots don't really change the energies. They're just being correct for the Lewis structure. And then we have HCl having this Lewis structure here. So now we need to look at the table. We need to figure out how much energy is present for those. So for the HH, that's 436 kilojoules per mole. For the Cl2, let's see here, Cl2, okay, it's 243 kilojoules per mole. And then the H and Cl are, where is it at here? There it is, 431 kilojoules per mole. So to calculate this, what we need to do, and this is what I always do, is I always separate the products and the reactants from each other. So I'm going to break everything on the left. I'm going to form it back on the right, since the products are being formed here. So on the left we have an HH bond, and we also have a Cl bond based off of the hydrogen and the chlorine gases. Now the energy of the HH bond is 436 kilojoules per mole. The energy for the chlorine is 243 kilojoules per mole. The next thing I want to do is look at how many bonds there are for each and what the balanced equation is. So for the hydrogen gas, there's one HH bond, and then there's only one for the coefficient. So that's where this number here comes from. It comes from the coefficient. Looking at the chlorine molecule, you have one Cl bond and there's only one for the balanced coefficient here. So we're going to multiply across, and then we're going to add those together. So we're going to have 436 plus 243. That gives me a total value of 679 kilojoules. Now that's on the left side. Now on the right hand side, we are going to form them back together. So we have HCl bond, and that bond has 431 kilojoules per mole of energy. Now there is one bond in that structure, but there's two molecules of HCl, so you have to multiply 2 times 1 times 431. So that gives me a value of 862 kilojoules. Now to figure out the enthalpy of reaction, what we have to do, and this is very simple to remember this, you have to do bonds broken minus the bonds that are formed. I'm running out of space. So it's always broken minus formed when you do this. So that way it keeps it straight for you. So we're going to take 679 kilojoules, and we're going to subtract it from 862 kilojoules. And so what you end up with is a value of negative 183 kilojoules. So that would be our enthalpy of reaction for that specific reaction. So to recap what I just did here. So the first thing you do is draw the Lewis structure. Then you look at the bond energies for the types of bonds that are present from the Lewis structures. You tally them up together in the broken. You tally them up for the formed. Remember, the broken represents the reactants. The formed represents the products. Make sure you draw that line, that middle barrier, so you don't get the products and reactants mixed up. You combine those together. You add up the enthalpies of reactions, or the bond energies, not enthalpies of reactions. Sorry about that. So you add them up, and then you plug them into the equation to solve for enthalpy of reaction, where you have broken minus formed. If you can keep that stuff straight, then you will end up with the right answer every time. And so, just like anything, it's one of those things where you have to just keep working on. So, if we look at another example here, and we're going to have CH3H plus Cl2 yielding CH3Cl plus HCl. Now these Lewis structures these are not much different from the previous one, but if you notice here, you have carbon with 3 hydrogens surrounding it, and you have that 4th hydrogen plus the Cl2 yields HCl plus HCl. So now the line is drawn here. So you're going to have broken, and you're going to have formed on this side here. See, it's a little different from the previous reaction we've done. So in this one, we have carbon hydrogen, and we have ClCl. So the carbon hydrogen is 414. The ClCl is 243. We have, so if you look at the CH3H, so that's CH4, so you have 4 CH bonds. You have 1, and now the balanced equation is 1. So we're going to do 1 times 4 times 414. That gives me 1656. And then we're going to add that to 243, because that's the Cl2. And that gives me 1899 kilojoules for the left-hand side, the reactants. Now we're going to go to the right-hand side. We see that we have a carbon hydrogen bond, and that's still 414. We have the carbon Cl bond, so it's a little different now. And then we have the HCl bond. So the carbon and chlorine is 339 kilojoules per mole. The HCl is 431 kilojoules per mole. So if we look at the balanced equation, we can see that there's still one of each, so each of these are going to be 1 times the number that you count. So the CH, there are 3, the CCl, there's 1, and the HCl, there's 1 here. So we're going to tally that up, so we're going to multiply across and then add them together. So 3 times 414 plus 339 plus 431, that gives me 2012 kilojoules for the product side. So to figure out the enthalpy of reaction, we're going to do 1,899 kilojoules minus 2012 kilojoules. Remember, it's broken minus formed. And what do we get here? We get negative 113 kilojoules for our enthalpy of reaction. So that's really what bond energies are. Bond energy is relating to the number of bonds that are being broken versus number of bonds being formed. And all that ties back into drawing the Lewis structures and having just a basic understanding of what's inside of that Lewis structure and how that plays a role in the overall enthalpy of reaction. If you have any questions or anything, just leave me a message or send me an email. Thanks.